Good morning, students. I am Sangeeta, lecturer in chemistry, branch general section, Institute GPT Narankhed, semester 1, subject general engineering chemistry, subject code 18C104F, major topic electrochemistry, duration 30 minutes, subtopic applications of electrolysis. So in that, today we'll study electroplating, teaching aids, PPT, diagrams, animations wherever required. Let us recollect what we have discussed in last class. So in last class, what we have discussed? We discussed electrolysis of aqueous NaCl. So once again, I will revise this electrolysis of aqueous NaCl. So how will you do the electrolysis of aqueous NaCl? So in the cell, we will take aqueous NaCl as an electrolytic solution. In that solution, we will dip two platinum rods, and these two rods are connected to the two poles of the battery. So whatever the rod connected to the positive pole of the battery is called anode, and whatever the rod connected to the negative pole of the battery is called cathode. So here we are using source for electric current battery. So by connecting this battery to these rods, the electric current will pass into the solution. When electric current will pass into the solution, whatever the ions already present in the solution, they will move to their respective electrodes. So here what are the ions present in the solution? So here we are taking aqueous NaCl solution. So here in aqueous NaCl solution, Na plus ions, Cl minus ions. In addition, these two ions and two more ions are present. That is H plus and OH minus ions. That means two cations are present and two anions are present in this solution. So on passing the electric current into the solution through these electrodes, whatever the cations present in the solution, they will move to the cathode. That is Na plus and H plus ions will move to the cathode. Similarly, whatever the anions present in the solution, that is Cl minus and OH minus ions will move to the anode. So what happens here at cathode? So hydrogen H plus ions undergoes reduction in preference to the Na plus ions. So hydrogen gas is liberated. So similarly here the Cl minus undergoes oxidation and liberates chlorine gas at anode. So at anode chlorine gas is liberated, at cathode hydrogen gas is liberated. Okay. So here, whatever the products present in the solution, the Na plus and OH minus ions will combine and forms a byproduct called as sodium hydroxide. So here, see the equations. Already I have given equations at cathode. So this is the reduction reaction. 2H plus 2 electrons, H2 gas, and here 2Cl minus gives rise to Cl2 plus 2 electrons. So that is Cl2 gas is formed. So always remember at anode oxidation, at cathode reduction. So what is oxidation? Losing of electrons. As it is having excess electrons, it will lose electrons and converts into chlorine gas. Here at cathode, as it is having short of electrons, it will gain electrons and forms hydrogen gas. So whatever the electrons lost by chlorine at anode, they will flow through this copper wire to the cathode. There, this H plus ions will take those electrons and convert into hydrogen gas. So this is about electrolysis of aqueous NaCl. The next today's topic is applications of electrolysis. So in that applications of electrolysis, we are going to study today electroplating. So here we have two applications, that is electroplating and electrolytic refining. So today we are going to discuss about this electroplating. So what are the objectives? On completion of this period, you will be able to understand total electroplating process. Okay. So what is electroplating? The process of coating of less active metal on the surface of more active metal by electrolysis process is called electroplating. So what is meant by electroplating? So we are depositing a metal over another metal. Okay, the process of coating a less active metal on the surface of more active metal. So what we are doing? We are coating less active metal on more active metal by electrolysis. So how we are coating? By electrolysis, we are coating one metal over another metal. So that process is called as electroplating. By electrolysis, we are plating the metal. So that's why this process is called as electroplating. So example, copper plating, nickel plating, chromium plating. That means we can plate these metals. We can plate copper metal, we can plate nickel metal, we can plate chromium metal. So in our syllabus, we have copper plating. So today we will discuss this copper plating. So we'll see the process here. In the electroplating process, the metal to be electroplated is taken as cathode. Okay, and the metal to be coated is taken as anode. So in the electroplating process, the metal to be electroplated is taken as cathode. So on whichever the metal you want to coat, that metal will be taken as cathode. And whatever the metal you are coating and the metal to be coated. So whatever the metal you are coating, that will be taken as anode, and the electrolytic solution is salt of anodic metal. So whatever the metal you are taking as anode, that will be your electrolytic solution. Okay, for example, if copper is anode, so copper sulfate solution will be taken as its electrolytic solution. The metal ions in electrolyte are reduced at cathode. Okay, whatever the metal ions present in the electrolyte, they will go to the cathode, and at the cathode they undergo reduction. So this is about electroplating. So what is electroplating? The process of coating less active metal over the more active metal by electrolysis is called electroplating. So in electroplating process, the metal to be electroplated, so on which you want to coat, that will be taken as cathode, and the metal to be coated, and whatever the metal you want to coat it on the other metal, that will be taken as anode. And what will be the electrolyte? Electrolyte should be of anodic metal. So whichever the metal you are taking as anode, that anodic metallic solution will be the electrolyte. And the metal ions in electrolyte are reduced where? They are reduced at cathode. It means metal ions present in the solution will move to the cathode, and after going to the cathode, they will undergo reduction. So and deposited on the surface of cathodic metal. So after going to the cathodic metal, so they undergo reduction. So after undergoing reduction, what happens? They will deposit on the surface of the cathodic metal. So whatever the metal ions going to the cathode, undergoing reduction, and what they are doing? They are depositing on the surface of cathodic metal. At the same time, equal number of cations are added to the electrolyte by oxidation of anodic metal. So here what is happening? So whatever the metal ions present in the solution, they are moving to the cathode and undergoing reduction. Meanwhile, what is happening here? Equal number of cations are added to the electrolyte. From where? By oxidation of anodic metal. So always at anode, which reaction will takes place? Oxidation. So what happens there? Anodic metal undergoes oxidation. So due to oxidation, some cations will be formed. So those cations will be added to the electrolyte. So this process is proceed until required thickness of metal is deposited on the cathodic metal. So this process will continue until required thickness. So whatever the thickness you want, that much thickness will be formed. There, that means it will proceed until that thickness will be formed. Okay, and that metal will go and deposit on the cathodic metal to get the required thickness. So this is about electroplating process. So in that electroplating, now we will discuss the copper electroplating. That means we are depositing copper. So in this process, the metal on whose surface copper is deposited as cathode and copper is taken as anode. Okay, the metal on whose surface copper is taken as cathode. So whatever the metal on which you want to deposit copper, that will be taken as cathode. For example, on zinc, say on zinc, on iron, you want to coat copper, that zinc will become the cathode and the copper will become the anode. You want to coat which metal? You want to coat copper metal, that copper will become anode. So whichever the metal you are coating, that will become anode. So on which you want to coat, that will become cathode. For example, on zinc you want to coat copper, so zinc will become cathode and this copper will become anode. That is the meaning here. In this process, the metal on whose surface copper deposited is taken as cathode. So for example, on zinc you want to coat this copper, that zinc will become cathode. If on iron you want to coat this copper metal, that iron will become cathode. And this we are coating what? Copper. So copper will become anode. And what is the electrolytic solution? This anodic salt solution only electrolyte. So here what is anode? Copper. So copper sulfate is taken as electrolyte. So the following reactions takes place. Okay, so here copper plating. So we are plating copper. So copper is anode and another metal is cathode and electrolytic solution is copper sulfate solution. So here we'll see the diagram first. So by electrolysis, we are doing electroplating. So we need electrolytic cell. So in that electrolytic cell, what we are taking here? So here we are doing copper plating. So anode will be copper rod. So this is the copper rod. So this is another rod on which we are coating copper. So whatever may be the rod, either zinc or either aluminum, whatever, another rod. Okay, what is the electrolytic solution? Copper sulfate solution. So what we are doing? So we are constructing a electrolytic cell. So constructing electrolytic cell means what you have to do? You have to connect these metal rods to the battery. So already we discussed battery has two poles. It is positive pole and negative pole. So here which rod is taken as anode? Copper rod is taken as anode. So this copper rod is connected to the positive pole of the battery. So whichever is connected to the positive pole of the battery, that is anode. And another metal is, so on which copper is depositing, that metal will become cathode. So that will be connected to the negative pole of the battery. So here anode is copper and another metal is cathode. So sorry, Anode is copper, and whichever the metal on which we are coating, that is cathode. So this is positive sign, this is negative sign. So here we are connecting battery, means what is happening? Electricity is passing into this electrolytic solution through this electrodes. So what happens here? In electrolytic cell, what happens? By passing electric cell, chemical reactions takes place. Whatever the ions present in the solution, they move to the respective electrodes and chemical reaction taking place. So here we are discussing about copper plating. So here we will discuss about this copper ions deposition only. So here what happens at anode? Oxidation takes place. So oxidation of this anodic metal. Okay, this copper rod itself undergoes oxidation. So Cu gives rise to Cu gives rise to Cu plus 2 electrons. So already some copper ions are present in the solution. And meanwhile what happens? This anodic metal is also undergoing oxidation. And Cu plus 2 ions will be entering into the solution. So here whatever the ions present in the solution and whatever the Cu plus 2 ions dissolved from this copper rod, they will move to the cathode. So after going to the cathode, what happens? Reduction taking place. So here at anode, this copper rod is dissolving and we are getting this copper plus 2 ions and electrons are releasing. And so whatever the electrons are releasing, they flow through this wire and go to the cathode. So here at the cathode, what are the ions present? Copper ions, Cu plus 2 ions are present. So what happens to this Cu plus 2 ions? They will undergo reduction. So at cathode, which reaction will take place? Reduction. What is reduction? Gaining of electrons by these copper ions. So when these copper ions gains these electrons, what happens? Copper metal is formed. So whatever the copper metal is forming, that copper metal will deposit on this cathode. So and this process will continue until required thickness of copper is deposited on this cathode. So after getting the required thickness of this copper, so you have to remove this cathode outside. Okay, like this we will do the electroplating of any metal. Okay, so here we have seen copper plating. Similarly, we can do nickel plating, chromium plating, like that. So if you want to nickel plating, so you anode will be nickel. If you want to plate chromium, anode will be chromium. So whatever the metal you want to coat it on the other metal. So here that metal will be taken as the anode. Okay, this is about electroplating. In that electroplating, we discussed copper plating. So uses of copper electroplating. So what are the uses of electroplating? So it is used to increase the tensile strength of the metal. So by plating one metal over the another metal, so what is happening? The tensile strength of the metal is increasing. What is mean by tensile strength? Stretching capacity. Okay, the stretching capacity will be increasing. Then what is the second application? It is used to increase the resistance towards corrosion and abrasion. So here generally electroplating is done for decoration purpose, for corrosion, for to prevent from corrosion and to prevent from abrasion. Okay, so if you coat another metal, so what is happening? It will increase the resistance towards corrosion and abrasion. The next, it is used in making jewelry. Even in electroplating, even this electroplating process is used in jewelry. So for some ornament, for silver ornaments, we will coat gold. So we are coating with gold. So that like that we can use electroplating. So it is this electroplating is also used in jewelry. Gold is plated on silver. Okay. Then next, to increase the decoration of the metal. So to enhance the beauty of the metal, so we will electroplate. So these are the some of the applications of electroplating. So what is the first application? It is used to increase the tensile strength of the metal. Then it is used to increase the resistance towards corrosion and abrasion. And it is used in making jewelry. And it also increases the decoration of the metal. So these are the applications of the electroplating. So here come to summary. So here, so in this period what we have discussed, we discussed process of electroplating, then uses of electroplating. So then come to objective type questions. So what type of objective type questions you may expect from this topic? So first question, very simple questions and direct questions. That is, what is the main principle of electroplating? So what is the main principle involved in electroplating? So here some options are given. A, hydrolysis. B, neutralization. C, esterification. D, saturation. So what is the answer? A, hydrolysis. So here hydrolysis is involving the electroplating. So answer is A. The next second question. Which of the following is not an application of electroplating? So here some options are given among these. Which is not the use of electroplating? So just now we studied the uses of electroplating. So here options we will see: decorative purposes, coating of metal, metal protection, and corrosion prevention. Okay, so among these, which is the not an application of electroplating? So decoration purpose we are using coating of metal, okay, metal protection. So corrosion, that means this electroplating will not prevent corrosion, just it will resist. Totally it will not prevent corrosion. So answer is D. So prevention of corrosion is not an application of electroplating. So next, third question, which of the following metals cannot be electroplated? So here some metals are given. So which of the following metals cannot be electroplated? So all metals are not electroplated. So few metals only electroplated. Okay. Generally here first in the definition itself we studied. So less active metal is coated on more active metal. Okay. So only few metals are electroplated. So among these metals, which is not electroplated, he is asking. So options A tungsten, B nickel, C silver, D copper. So copper can be electroplated, silver can be electroplated, nickel. So answer is A. Okay. So tungsten cannot be electroplated. Next, fourth question. In electroplating, the solution must be of the salt of the metal should be of. In electroplating, the solution must be of the salt of the metal should be of. A, substance that has to be electroplate. B, iodine. C, chlorine. D, sodium. So in electroplating, so among these options, which is the salt of the metal should be of? So once again we'll read the question. In electroplating, the solution must be of the sort of what he is asking. So whatever the electrolyting solution we are taking in the electroplating, so that solution must be of what among these? Either sodium? No. Either chlorine? No. Either iodine? No. So what is the answer? Substance that has to electroplate. So already while discussing electroplating only, I repeated 2-3 times. So what is the electrolytic solution? Whichever metal we are depositing, that metallic solution will be the electrolytic solution. For example, copper we want to deposit or copper we want to plate. That copper sulfate will be the solution. Okay, zinc if you want to deposit, zinc sulfate solution will be the electrolyte. So that's only he is asking. Okay, so here. So what is the answer? Substance that has to electroplate. That means whatever the substance we are plating, that should be the salt of that solution. Okay, answer is A. So then come to the questions. So what type of questions you get from this topic? So direct questions, that is explain copper plating and write applications of electroplating. So explain copper plating means direct, you can write the copper plating. If you, they will ask write about electroplating means, so you have to write from here. So first of all, what is electroplating you have to write. And so what is happening in this electroplating you have to write. First write the definition of electroplating. So that's the process of coating of less active metal on the surface of more active metal by electrolysis process is called electroplating, and you have to give few examples. So in the electroplating process, what we are doing, the metal to be electroplated is taken as cathode and the metal to be coated. It means whatever the metal you want to coat, that will be taken as anode, and the electrolyte will be the salt of that anodic metal. So in the process what is happening, the metal ions in the electrolyte are reduced at the cathode and they will go and deposit on the surface of the cathodic metal. In the meanwhile, what is happening, equal number of cations are added to the electrolyte. How? By oxidation of anodic metal. That means anodic metal is undergoing, that metal itself undergoing oxidation. So from that metal, metal ions will be coming out and they will go into the solution. After going into the solution, they will move to the cathode. After moving to the cathode, they will undergo reduction. After reduction, that metal will be coated on the cathode. So like this process will takes place. Like this you have to explain the electroplating. If copper plating is, so here you have to discuss about copper only. That means copper we are plating. So first you have to draw the diagram. So by the diagram you can easily explain the process. So for copper plating, we will take electrolytic cell. In the electrolytic cell, copper sulfate solution is the electrolyte. So copper is the anode, and on which metal we are coating, that will become cathode. So here, and these two are connected to the battery. So copper is connected to the positive pole of the battery, and other metal on which we are coating, that will be connected to the negative pole of the battery. So here what is happening, after connecting, electricity will pass into the solution. So here at anode oxidation takes place, means this anode rod itself, this copper rod itself undergoes oxidation. So like this, Cu gives rise to Cu plus 2 electrons. So these Cu plus 2 ions goes into the solution, and whatever the Cu plus 2 ions already present in the solution, and whatever the Cu plus 2 ions coming from this rod, they will move to the cathode and there they will undergo reduction like this equation. Cu plus 2 electrons and forms copper metal. So whatever the copper metal is formed, that will deposit on this cathode. So this process will continue till the required thickness of copper is obtained on this metal. So then you have to remove this battery and you have to remove this cathode, then you will get that metal with copper plating. So like this we will do the copper plating. Okay. If you have any doubts, we will discuss in the next class. So this is the first application of electrolysis. So we have one more application, that is electrolytic refining, that we will discuss in the next class. Okay, so that is first application is electroplating. Electroplating means through electrolysis we are coating one metal over another metal. So one metal means that is less active metal is coated on more active metal. So for what purpose we are coating? So it may be decoration purpose, okay, it may be resistant to corrosion, to increase the tensile strength. For these purposes, we are coating one metal over another metal. So we finished electroplating process. In the next class, we will deal with electrolytic refining, and this question is very important, maximum times repeated. Explain copper plating. So these applications rarely they will ask, but explain copper plating for 5 marks with diagram. If they will mention or not mention, you have to draw the diagram, you have to write the equation, and you have to give the explanation. Explain means you have to draw the diagram, you have to write the equations, and you have to explain the whole process. And these applications for 1 mark question, either 1 mark or 3 marks questions. And this copper plating process will be for 5 marks questions. Maximum times repeated this question. Okay, thank you students.